Evening, sir. I'm Shivam Dixit with my partner YASH Bahuguna. We have made a game using PIC and LCD display as part of our embedded systems project. So, the basic premise of the game is that the player, denoted by P, has to find the end of the path, has to move from start to finish while avoiding the hidden obstacles that come in its way. So, as soon as the player hits an invisible obstacle, his position is reset to the starting position. We use four buttons to control the movement of the player, which can be observed on the LCD display. And it is quite simple since in this game, the only way to lose is when you give up trying.
This is the Proteus simulation for the game, and we need to press a key to start. We can go right by pressing this, and we entered an invalid block. Let us go any further. So we need to find a path to the end, and again we messed up. One, two, so three. 3, 4, 5, 6. Okay. I am having trouble beating this. Oh, 6, 2, 3. Oh, cool. So, yeah, we didn't lose, we won. And that's about it. So, every time we play the game, we need to generate a random path from start to finish. Generating this random path is a problem because generating random numbers is a problem in computer science. Shuffling is a problem in computer science. There's many algorithms associated with random number generation, but they're all pseudo random number generation algorithms. There's no shuffle, and there are other ways to generate some semblance of something random happening on a machine. So we tried that too. So so the game, this is a 16 by 2 LCD display. So the game, every time it generates a different path from start to finish. So how did we achieve that? So here's the player. So what happens is when the start screen for the game comes, we have to press a button to start the game. So what is happening while the start screen is displaying, a timer is running in the background, and as soon as the presses start, so an 8-bit register is there, and it's incrementing its value every time the every microsecond or so. So it's free running and it loops around, and as soon as the player presses start, at that instant, whatever the value there is in this register, it is stored. So the value in this register decides what will be the path that is a valid path across the game board. So suppose the value is this. So the same value is copied into another register to make this 16-bit, and so these same values will be here. And what will happen after that is, if I have a 1 here, that means from the beginning, as soon as I get a 1, I'll switch my lane. I have to switch my lane in the path. And if there's a 0 here, then continue on the same path. So for this configuration, the path will be, there's a 1, so I have to switch here. Then there's a 0, I don't have to switch. Then there's a 1, I have to switch. Then there's a 0, I don't have to switch here. Then again, I don't have to switch. Then uh, here there's a 1, so I have to switch. Then there's a 0, so I don't have to switch. And again, there will be a 1 here and a 0 here, and because the same register is copied here. So that's how we're generating a random path each time the game is being played. So there will be a total of 256 possible paths, because this 8-bit register will take 256 different values, and the same values are copied to the second register also. So there will be 256 unique paths from starting to ending of the game. So that is some pseudo random number generation in assembly. That is, all of this was done in assembly. All of this is assembly code for big microcontroller. Uh, this is the circuit for it. There's a microcontroller. There's an LCD, 4 buttons, and that is about it.